Hello there, and welcome to the Silent Scientist channel. Tonight, we journey into a world of communication that requires no words, no sounds, no deliberate thought. A language older than speech itself, more honest than any conversation, and more revealing than any confession. Tonight, we explore the hidden language of the human body. Right now, as you settle into comfort, your body is speaking. Your cells are exchanging millions of chemical messages every second. Your face is making micro adjustments too quick for conscious awareness. Your posture is telling a story about how you feel. Your autonomic nervous system is broadcasting signals you cannot control. Every heartbeat, every breath, every subtle shift carries meaning in a vast, intricate network of communication that has been humming along since the moment you were born. This language existed long before humans developed words. Our ancestors read each other's bodies to detect danger, assess trustworthiness, identify potential mates, and maintain social bonds. Today, even as we've built towering structures of verbal language, this ancient system continues to operate beneath the surface, often saying more than our words ever could. When your friend says they're fine but their shoulders slump, when a stranger's pupils dilate when they see you, when your own hands clench before you even register feeling angry, the body is talking, always talking, in a language we're only beginning to fully understand. If you enjoy these explorations into the mysteries of science and the human experience, I invite you to like this video, subscribe to the channel, or share a thought in the comments below. It helps others find their way here, one curious mind at a time. But for now, settle in. Let your thoughts grow soft and your breath deepen. We have much ground to cover in this silent conversation. Let us begin. The face, our most expressive canvas. Your face is a marvel of mechanical precision and emotional broadcasting. Beneath the skin lie 43 individual muscles, each capable of contracting independently or in concert with others. These muscles don't just shape your expressions for others to see. They're connected directly to your emotional centers, creating a two-way conversation between feeling and form. When you smile, you don't just look happy. The physical act of smiling can actually shift your emotional state toward happiness. The face is both transmitter and receiver, both consequence and cause. Scientists estimate that the human face can produce up to 10,000 distinct expressions. Most of these are subtle variations, tiny shifts in muscle tension that change meaning by fractions of a millimeter. A genuine smile activates the orbicularis oculi muscle around the eyes, creating the crow's feet that we associate with real joy. A false smile uses only the zygomatic major muscle to lift the corners of the mouth, but the eyes remain unchanged, giving us that instinctive sense that something is off, that the emotion isn't quite real. This distinction was first seriously studied in the 1860s by a French neurologist named Guillaume Duchenne, who used electrical stimulation to map facial muscles and their associated expressions. He discovered that only genuine emotion activates certain muscle combinations, particularly around the eyes. Today, we call authentic smiles Duchenne smiles in his honor, recognizing that the face can betray truth even when the mind wishes to deceive. But perhaps the most fascinating discovery about facial expressions came in the 1960s, when researchers Haggard and Isaacs were studying couples in therapy. While reviewing film footage frame by frame, they noticed something extraordinary. Expressions would flash across faces so quickly, lasting only a fraction of a second, that they were impossible to detect at normal speed. These micro-momentary expressions, later renamed micro-expressions, revealed emotions that people were trying to conceal. A flash of anger before a forced smile, a moment of fear before composing oneself, a flicker of contempt so brief it vanished before conscious awareness could catch it. The discovery of micro-expressions revolutionized understanding of emotional communication. Previously, researchers focused on sustained expressions that lasted long enough for conscious observation. Micro-expressions revealed a deeper layer, brief emotional truths leaking through before voluntary control could suppress them. This finding had profound implications, suggesting that complete emotional concealment might be neurologically impossible. The brain's emotional centers respond faster than its conscious control centers, creating a window where truth shows before lies can be assembled. The mechanics of micro-expression production illuminate the tension between automatic and controlled processes in the brain. When we experience an emotion, the amygdala and related limbic structures immediately begin orchestrating the appropriate expressive response. Facial motor neurons fire, muscles begin contracting, and an expression starts forming. Simultaneously, if we wish to conceal the emotion, prefrontal cortex regions responsible for voluntary control attempt to override this automatic response. The micro-expression represents the brief period before voluntary control fully engages, a glimpse of authentic emotion before the social mask can be secured. Not all emotions produce equally detectable micro-expressions. Anger, fear, and disgust seem particularly prone to leaking through attempted suppression, perhaps because these emotions evolved as threat responses, where speed mattered more than subtlety. Sadness and happiness produce somewhat less pronounced micro-expressions when suppressed, possibly because these emotions emerged in contexts where gradual expression was acceptable. The specific patterns vary by individual too. Some people suppress more effectively than others, and certain emotions prove easier or harder for given individuals to conceal based on personality, experience, and neural architecture. Cultural display rules interact intriguingly with micro-expressions. While the basic expressions themselves appear universal, cultures vary tremendously in which emotions people are encouraged or discouraged from displaying openly. In cultures emphasizing emotional restraint, people become more practiced at suppression, potentially reducing micro-expression visibility through extensive practice. Yet complete elimination appears impossible. Even highly trained individuals in cultures strongly emphasizing emotional control still produce detectable micro-expressions under appropriate observational conditions. Dr. Paul Ekman expanded on this work in the 1970s and 1980s, traveling to remote cultures around the world to test whether facial expressions were universal or culturally learned. He visited indigenous tribes in Papua New Guinea who had never been exposed to Western media or culture. When he showed them photographs of faces displaying emotion, they identified the same emotions that Westerners would identify. Happiness, sadness, anger, fear, surprise, disgust, and contempt appeared to be recognized across all human cultures, suggesting these expressions are hardwired into our biology rather than learned through social conditioning. Later research with individuals born blind confirmed this remarkable finding. Despite never seeing a face, Blind individuals produce the same facial expressions as sighted people when experiencing emotions. An athlete born blind displays the same expression of triumph when winning as a sighted athlete. A child who has never seen sadness still furrows their brow and turns down their mouth corners when distressed. This tells us that facial expressions are not learned by observation. They're embedded in the architecture of the human nervous system itself, controlled by ancient brain structures that predate conscious thought. The speed at which micro-expressions occur is startling. Most last between 1/15th and 1/5th of a second. They emerge from the amygdala, the brain's emotional center, before the prefrontal cortex, the seat of conscious control, can intervene. This creates a brief window where true feelings leak through before the social mask can be put in place. A person telling a lie might display a genuine micro-expression of stress or guilt before arranging their face into a convincing expression of innocence. But reading these expressions accurately requires training and context. Research shows that most people without training can detect micro-expressions with only about 50% accuracy. Basically random chance. However, certain groups perform better. Secret Service agents, trained to watch for threats, achieve around 64% accuracy. People who work extensively with emotions, therapists, nurses, caregivers, can reach 68 to 73% accuracy with the same training that others receive, suggesting that emotional intelligence plays a crucial role in decoding these fleeting signals. The eyes themselves carry enormous communicative power. When surprised, our eyes widen involuntarily, exposing more of the white sclera. This serves a dual purpose. It allows us to take in more visual information about whatever surprised us, and it signals to others exactly what has captured our attention. Interestingly, widening the eyes also makes us appear more trustworthy. Research from New York University in 2014 found that people who widened their eyes during questioning were perceived as more honest, perhaps because the gesture mimics the surprise of someone wrongly accused. Eye contact itself carries complex meaning that varies across cultures. In Western societies, direct eye contact generally signals confidence, attention, and honesty. But the duration matters enormously. Too little eye contact, breaking away constantly, or refusing to meet someone's gaze can suggest shyness, deception, discomfort, or even guilt. In negotiations, someone who consistently avoids eye contact may appear uncertain about their position or hiding information. In romantic contexts, insufficient eye contact might signal disinterest or emotional distance. Conversely, too much eye contact creates different problems. Prolonged, unbroken staring can feel aggressive, confrontational, or socially inappropriate, triggering discomfort in the recipient. The intensity of sustained eye contact activates threat detection systems in the brain, likely an evolutionary holdover from when being stared at often preceded violence or predation. In many social contexts, this triggers an urge to look away or even physically retreat. The sweet spot is typically 3 to 5 seconds of sustained contact before glancing away naturally, perhaps to gesture or gather thoughts, then returning to reconnect. Cultural variations in eye contact expectations create significant potential for misunderstanding across different social groups. In other cultures, however, prolonged eye contact can be seen as disrespectful or confrontational, particularly when directed at authority figures or elders. In many Asian, African, and Latin American cultures, Lowering the gaze when speaking to someone of higher status demonstrates respect rather than deception or weakness. Children raised in these cultural contexts learn early that direct eye contact with parents, teachers, or elders signals defiance or insolence. A respectful child looks down or to the side while listening to correction or instruction. Gender differences in eye contact patterns exist across many cultures. Women generally maintain eye contact more consistently during conversations than men, both when speaking and when listening. This difference may relate to socialization patterns that encourage women to attend closely to social and emotional cues, while permitting men greater emotional distance. Same gender conversations typically involve more eye contact than cross-gender interactions, where cultural norms about appropriate behavior between men and women shape these subtle choices. Neurodevelopmental differences also affect eye contact patterns. Individuals on the autism spectrum often find direct eye contact uncomfortable or overwhelming, experiencing it as physically painful or emotionally intense rather than connective. For them, looking away isn't avoidance or disinterest. It's sensory management, allowing them to process what's being said without the added cognitive load of managing facial expression interpretation and eye contact simultaneously. Understanding this prevents misinterpretation of their body language. Pupil dilation occurs automatically in response to emotional arousal, whether that arousal is positive or negative. When we see something that interests or attracts us, our pupils expand to take in more information. When we experience fear or stress, the same dilation occurs to maximize visual awareness. Skilled poker players watch their opponent's pupils for signs of a good hand. Researchers studying attraction measure pupil size as an involuntary indicator of interest. Your pupils are constantly revealing your level of engagement with the world, expanding and contracting in a dance you cannot consciously control. Even the smallest movements around the eyes convey meaning. A genuine laugh produces a squint that pushes the lower eyelid upward, creating temporary wrinkles. A forced laugh leaves these muscles relaxed. Nervous tension might cause rapid blinking, while intense concentration slows the blink rate. When someone blocks their eyes with their hands or briefly closes them during conversation, it often indicates disagreement, distress, or a desire to shut out disturbing information. The eyes, it turns out, are not just windows to the soul. They're neon signs broadcasting our inner state to anyone who knows how to read them. The mouth, too, speaks in countless subtle ways. Lip compression, where both lips press together in a thin line, often indicates stress, disagreement, or withheld information. A lip bite can signal anxiety or self-restraint. When one corner of the mouth turns up while the other remains level, it typically expresses contempt or disdain, a particularly reliable indicator of negative judgment towards someone or something. Interestingly, some people are born with an enhanced ability to control their facial expressions. These individuals, sometimes called natural liars, can suppress micro-expressions more effectively than average. But even they cannot eliminate these telltale flashes entirely. The ancient structures of the brain insist on having their brief say before the conscious mind can fully censor the message. The face, it seems, is determined to tell the truth, even if only for a fraction of a second. Cellular conversations, the body's internal language. while we communicate with others through facial expressions and body language, our cells are conducting their own intricate conversations every moment of every day. This cellular communication is perhaps the most fundamental form of language in the human body, a chemical dialogue that has been perfected over billions of years of evolution. Inside you right now, trillions of cells are sending and receiving messages. These messages take the form of chemical compounds called signaling molecules, hormones, neurotransmitters, growth factors, and countless other molecular messengers. Each cell must know when to divide, when to grow, when to move, when to perform its specialized function, and when to die. Without this constant flow of information, your body would collapse into chaos within moments. Cellular communication operates through several distinct mechanisms, each designed for different ranges and purposes. The simplest form is called autocrine signaling, where a cell sends a message to itself. This might sound strange. Why would a cell need to talk to itself? But autocrine signaling plays crucial roles during development and in maintaining cellular identity. A developing embryo cell might secrete a growth factor that binds to receptors on its own surface, reinforcing its role and ensuring it continues down the correct developmental pathway. Juxtacrine signaling occurs between cells in direct physical contact. Specialized proteins on one cell's surface interact with receptors on an adjacent cell's surface, like two people shaking hands. This type of communication is essential during embryonic development, when cells must coordinate closely to form organized tissues and organs. It also plays vital roles in the immune system, where immune cells must physically contact other cells to determine if they're healthy or infected. Paracrine signaling extends the conversation to nearby cells without requiring direct contact. One cell secretes molecules that diffuse through the surrounding fluid to affect cells in the immediate vicinity. This local communication allows groups of cells to coordinate their activities. In your brain, for instance, neurotransmitters released by one neuron float across the tiny synaptic gap to affect neighboring neurons, allowing thoughts to ripple through neural networks at lightning speed. Paracrine signals are typically short-lived, either quickly degraded by enzymes or absorbed by nearby cells, ensuring that the message stays local and doesn't spread where it's not needed. The most far-reaching form of cellular communication is endocrine signaling, where specialized cells release hormones directly into the bloodstream. These chemical messengers can travel throughout the entire body, reaching distant organs and tissues. The pituitary gland at the base of your brain, for instance, releases growth hormone that travels through your blood to affect cells in your bones, muscles, and organs throughout your body. Your thyroid releases hormones that regulate the metabolic rate of nearly every cell you possess. The endocrine system is essentially a chemical postal service, delivering messages to specific zip codes throughout your body. The lock and key specificity of cellular signaling is remarkably precise. A signaling molecule or ligand will only affect cells that have the correct receptor for that molecule. Think of it like a radio broadcast. The signal is everywhere, but only radios tuned to the right frequency can receive and interpret the message. This specificity allows a single hormone to produce different effects in different tissues, depending on which cells have receptors for that hormone and how those cells are programmed to respond. When a signaling molecule binds to its receptor, it initiates what scientists call a signal transduction cascade. This is a series of molecular events inside the cell, like a row of dominoes falling, that amplifies the original signal and produces a cellular response. A single molecule binding to a receptor on the cell surface might trigger the activation of dozens, then hundreds, then thousands of molecules inside the cell, creating a powerful response from a seemingly small initial signal. This amplification is crucial for cellular efficiency. Rather than requiring massive amounts of signaling molecules to achieve a response, cells can detect minute quantities and magnify that initial signal internally. Think of it like a whisper that starts an avalanche. The original stimulus might be tiny, but the cascade it triggers transforms that whisper into a roar. Each step in the cascade involves proteins activating other proteins, often through chemical modifications like adding or removing phosphate groups, which flip molecular switches and propagate the signal deeper into the cell. Different types of cascades produce different cellular outcomes. Some trigger changes in gene expression, turning specific genes on or off to produce new proteins. Others activate enzymes that modify existing proteins, changing their function or location within the cell. Still others open or close ion channels in the cell membrane, changing the electrical properties of the cell or allowing specific molecules to enter or exit. The versatility of signal transduction allows cells to produce highly specific responses to countless different stimuli. Timing matters enormously in these cascades. Some responses happen within seconds. Muscle cells contract almost instantly when stimulated by acetylcholine from neurons. Others unfold over hours or days. Growth factors trigger cell division, but the actual process of DNA replication and cell splitting requires extended time. Cells use different cascade architectures to achieve different temporal profiles, matching the speed of their response to the nature of the challenge or opportunity they face. Some receptors sit on the cell surface, designed to catch large or water-soluble molecules that cannot easily pass through the cell membrane. When activated, these receptors trigger changes inside the cell without the signaling molecule ever entering. Other molecules, particularly small, lipid-soluble compounds like steroid hormones, can slip directly through the cell membrane and bind to receptors inside the cell, even inside the nucleus, where genetic material is stored. These internal receptors often function as transcription factors, directly influencing which genes get turned on or off. The complexity and coordination required for this system to function smoothly is staggering. Researchers have mapped the interactions of 642 different ligands binding to 589 different receptors across 144 different cell types in the human body. Most cells express dozens or even hundreds of these ligand receptor pairs, creating a densely interconnected communication network. A single cell might be receiving multiple signals simultaneously, each one influencing its behavior in different ways. The cell must integrate all these messages, weighing their relative strengths and priorities, and then produce an appropriate response. Consider what happens when you encounter something frightening. Your amygdala, deep in your brain, recognizes the threat and initiates a complex cascade of cellular communication. Neurons in your hypothalamus begin secreting corticotropin-releasing hormone, which travels a short distance to your pituitary gland. The pituitary responds by releasing adrenocorticotropic hormone, into your bloodstream. This hormone reaches your adrenal glands, sitting atop your kidneys, which then flood your blood with cortisol and adrenaline. These stress hormones travel everywhere, binding to receptors on cells throughout your body. Your heart rate increases, your pupils dilate, your liver releases stored glucose for energy. Your immune system temporarily suppresses non-essential functions. Blood flow redirects to major muscle groups. All of this happens in seconds, orchestrated by millions of cellular conversations, happening simultaneously across multiple organ systems. When cellular communication breaks down, disease often follows. In Graves' disease, antibodies mistakenly bind to thyroid receptors, mimicking the signal from thyroid-stimulating hormone. The thyroid gland, receiving what it interprets as constant instructions to produce hormones, goes into overdrive, producing excessive amounts of thyroid hormone. This causes racing heartbeat, tremors, bulging eyes, and metabolic chaos. The disease emerges not from damaged cells, but from confused communication, the molecular equivalent of sending the wrong message. Cancer, too, often involves communication failures. Normal cells receive signals telling them when to divide and when to stop. These signals maintain the careful balance between growth and restraint that keeps tissues healthy. But cancer cells develop mutations that disrupt signal reception or processing. A cell might lose the receptor for stop growing signals or gain the ability to send keep dividing signals to itself constantly. The result is uncontrolled growth as the cell becomes deaf to the body's regulatory messages. Type 2 diabetes involves a different kind of communication breakdown. Cells throughout the body develop insulin resistance, meaning they stop responding properly to insulin's signal to take up glucose from the bloodstream. The pancreas tries to compensate by producing more insulin, essentially shouting the same message louder, but eventually even this isn't enough. Blood sugar rises, and the carefully balanced system of glucose regulation falls into disorder. At the most fundamental level, cellular communication reflects a profound biological truth. No cell is an island. Each one exists as part of a vast community, and that community can only function through constant, precise communication. When the conversation flows smoothly, we experience what we call health. When messages get garbled, delayed, or misunderstood, illness emerges. Interestingly, this cellular language shares deep similarities with the body language we use to communicate with others. Both systems operate largely below conscious awareness. Both convey information through specific signals that must be correctly received and interpreted. Both can be disrupted by environmental factors or internal problems. And both are far older than our capacity for speech, refined through millions of years of evolution into remarkably efficient systems for sharing information. Your body is, in essence, a vast conversation. Cells talking to cells, organs coordinating with organs, systems integrating with systems. Every sensation you experience, every movement you make, every thought you think emerges from this intricate web of chemical dialogue. Right now, as you read these words, millions of conversations are happening inside you that you will never consciously perceive, but that are absolutely essential to your continued existence. Zautasem, the language of posture and gesture. While your face and cells conduct their quiet conversations, your body as a whole is making bold statements about your inner state. The way you stand, sit, move, and position yourself in space communicates volumes to anyone who takes the time to observe. This physical language, like facial expressions, operates mostly below the threshold of conscious awareness, yet it powerfully shapes how others perceive and respond to you. Posture serves as a foundation for body language, immediately conveying information about confidence, mood, and social status. Stand tall with shoulders back and chest open, and you project assurance and capability. The body takes up space freely, suggesting comfort with one's place in the world. Slump forward with rounded shoulders and a downcast gaze, and the message shifts dramatically. Here is someone burdened, defeated, or withdrawing from social engagement. This connection between posture and psychology works bidirectionally. Just as your emotional state affects your posture appears to influence your emotional state. Some research has suggested that holding expansive, open postures may make people feel more powerful, though the mechanisms behind this remain under investigation. While early studies claimed dramatic hormonal changes from brief postural adjustments, subsequent attempts to replicate these findings have produced mixed results. What does seem consistent across studies is that how we hold our bodies can subtly shift how we feel in the moment, the body influencing the mind in ways we're still working to fully understand. In social hierarchies, posture often reflects and reinforces power dynamics. Watch a corporate meeting, and you'll see these patterns play out unconsciously. The person at the head of the table typically adopts an open, expansive posture, leaning back in the chair, taking up space, perhaps with hands behind the head. Subordinates tend to make themselves smaller, leaning forward attentively, keeping their limbs closer to their body. These postural differences happen automatically, shaped by internalized understanding of social rank. The hands, freed from locomotion by our bipedal evolution, have become extraordinary instruments of communication. We gesture constantly while speaking, our hands helping to shape thought and convey meaning in ways that complement or even supersede words. When describing something tall, your hands rise. When indicating something tiny, your thumb and forefinger pinch together. When expressing uncertainty, your palms turn upward and outward in a universal gesture of openness and not knowing. Some gestures carry specific, culturally agreed upon meanings. A thumbs up signals approval in many Western cultures, but is considered highly offensive in parts of the Middle East and West Africa. The OK sign, formed by touching thumb and forefinger in a circle, means different things across cultures, from approval to insults to representing amounts of money. A nod typically means yes across most cultures, yet in some parts of Bulgaria, Greece, and Turkey, shaking the head from side to side indicates agreement, while nodding means no. But many hand gestures convey meaning that transcends cultural boundaries. Pointing directs attention towards something of interest, a behavior that emerges in human infants around 9 months of age and appears to be uniquely human among primates. Opening the hands wide suggests honesty and openness, as if showing there's nothing hidden in the palms. Clenched fists signal tension, anger, or determination. These basic gestures seem to tap into something fundamental about the human experience, communicating across linguistic and cultural divides. The spacing between fingers reveals information too. When feeling confident and relaxed, the space between fingers naturally increases. Under stress or insecurity, the fingers tend to press together, creating a more compact hand position. Even the simple act of showing the palms versus keeping them hidden carries meaning. Open palms suggest honesty and receptivity, while hidden hands can create a subtle sense of guardedness. Steepling the fingers, where the fingertips touch while the palms remain apart, typically indicates confidence or contemplation. You'll often see this gesture when someone is thinking through a problem or feels assured about their position. Conversely, wringing the hands or rubbing them together repetitively signals anxiety or self-soothing behavior. The hands serve as emotional barometers, constantly broadcasting our inner state through small, often unconscious movements. Touch represents perhaps the most direct form of body language, conveying emotions and intentions through direct physical contact. The appropriateness and meaning of touch vary dramatically across cultures and contexts. A hand on the shoulder can express congratulations, sympathy, or dominance depending on the relationship and situation. Research has shown that brief, appropriate touches can increase trust, cooperation, and even tipping behavior in restaurants. In many cultures, a firm handshake serves as a crucial first impression. Too weak and you might seem timid or disengaged. Too strong and you risk appearing aggressive or compensating for insecurity. The ideal handshake matches the other person's pressure, lasts about 3 seconds, and involves 1 or 2 pumps of the arms. Yet even this seemingly simple gesture carries layers of meaning about confidence, respect, and social awareness. Personal space, the invisible bubble we maintain around our bodies, serves as another dimension of physical communication. Anthropologist Edward T. Hall identified 4 distinct distance zones in American culture: intimate distance, touching to 18 inches, personal distance, 18 inches to 4 feet, social distance, 4 to 12 feet, and public distance, 12 feet or more. We allow different people into different zones based on our relationship with them and the context of the interaction. When someone invades our personal space without permission, we typically experience discomfort and may unconsciously step back or create barriers with our arms or belongings. Conversely, when we feel drawn to someone, we naturally reduce the distance between us, unconsciously communicating our desire for connection. Cultural norms around personal space vary significantly. What feels comfortable in Sao Paulo might feel uncomfortably close in Stockholm. Mirroring or mimicry represents a subtle but powerful form of body language that strengthens social bonds. When people feel rapport, they unconsciously begin to mirror each other's postures, gestures, and even breathing patterns. If one person leans forward, the other might do the same a moment later. If one crosses their legs, the other follows suit. This synchronization happens without deliberate thought, orchestrated by mirror neurons in the brain that fire both when we perform an action and when we observe someone else performing that action. Skilled communicators sometimes use intentional mirroring to build rapport and trust. Though this technique requires subtlety to avoid seeming manipulative or obvious, the natural version happens automatically and bi-directionally. Both people mirror each other in a dance of unconscious coordination. When mirroring breaks down, when one person's body language suddenly diverges from the other's, it often signals discomfort, disagreement, or emotional disconnection. Leg position and foot direction also communicate, though people pay less conscious attention to the lower body and thus control these signals less carefully. Feet typically point toward what interests us or where we want to go. If someone's feet point toward the exit during a conversation, they may be signaling a desire to leave, even if their upper body remains oriented toward you. Leg crossing can indicate either closure and defensiveness or simply comfort, depending on the overall cluster of body language signals present. Fidgeting, tapping feet, bouncing knees, playing with objects generally indicates restlessness, nervousness, or excess energy seeking an outlet. It's what researchers call an adapter, a behavior that helps us cope with stress or discomfort. While fidgeting doesn't necessarily indicate deception, it often accompanies feelings of anxiety or impatience. Conversely, unusual stillness can also signal stress, as when someone consciously tries to control their body to avoid revealing nervousness. The way we orient our bodies during interaction carries meaning too. Facing someone squarely suggests full engagement and attention. Angling the body away while continuing to talk signals divided attention or a desire to disengage. Standing side by side rather than face to face can reduce confrontational tension, which is why walking together while having a difficult conversation sometimes works better than sitting across from each other. All these postural and gestural signals must be read in context and in clusters. A single gesture rarely tells a complete story. Is someone crossing their arms because they disagree, because the room is cold, because they're simply comfortable that way, or because they're unconsciously mimicking someone else? The answer requires observing the whole person, considering the situation, and noticing how different signals cluster together to form a more complete message. The voice beyond words. When you speak, your words carry only a fraction of your message. The majority of what you communicate travels through channels that bypass language entirely. The tone, pitch, volume, rhythm, and quality of your voice. This acoustic landscape, called paralanguage, adds layers of meaning that can reinforce, contradict, or completely transform your verbal content. Your voice originates from the precise coordination of your respiratory system, larynx, and articulatory structures. As air from your lungs passes through your vocal folds, causing them to vibrate, you create sound. But the particular quality of that sound, its pitch, timbre, and resonance, carries emotional information before a single word is articulated. A voice tight with tension sounds different from a voice relaxed and open. Anger adds hardness to vocal tone. Sadness softens it. Fear raises pitch and quickens rhythm. These qualities emerge automatically from the physiological changes that accompany different emotional states. Pitch variation throughout speech conveys information about your emotional state and the meaning you're trying to emphasize. In most languages, statements typically end with falling pitch, while questions rise at the end. But subtle pitch changes within sentences highlight which words carry the most importance. Say, "I didn't take your keys" 7 times, emphasizing a different word each time, and notice how the meaning shifts dramatically, even though the words remain identical. The melodic contour of speech, its prosody, can completely alter interpretation. Volume serves as another carrier of emotional information. Loudness often accompanies anger, excitement, or urgency. Softness suggests intimacy, sadness, or hesitation. But volume also reflects cultural norms and individual personality. What seems like normal speaking volume in one cultural context might be perceived as aggressive or timid in another. The dynamic range of someone's voice, how much their volume varies throughout conversation, also communicates. A monotonous, unchanging volume can signal depression, disinterest, or careful emotional control. The rate of speech betrays much about internal state. When anxious or excited, people typically speak faster, their words tumbling over each other in a rush to express themselves. Slow, measured speech can indicate careful consideration, fatigue, or sadness. Strategic pauses add weight to certain phrases, giving listeners time to absorb important information. The absence of natural pauses, conversely, can suggest anxiety or an attempt to dominate the conversation by not leaving space for others to interject. Vocal quality or timbre, the unique color of your voice, emerges from the specific resonant characteristics of your vocal tract. This quality provides continuity, allowing others to recognize your voice even across phone calls or recordings. But vocal quality also shifts with emotion and physiology. Tension tightens the throat, creating a strained or pinched quality. Relaxation opens resonant spaces, producing a fuller, warmer sound. Even subtle changes in breathing pattern affect vocal quality, which is why stress so often colors how we sound. Fillers and hesitations, the ums, ahs and ahs that pepper spontaneous speech, communicate uncertainty, thinking in progress, or discomfort. While public speakers often work to eliminate these markers, they serve important conversational functions. They hold the floor while we formulate thoughts, signal to listeners that we're not done speaking, and make speech sound more natural and human. The complete absence of fillers can make speech seem rehearsed or unnatural. Laughter serves as a particularly interesting vocal signal, communicating far more than simple amusement. Real laughter emerges spontaneously, involving specific breathing patterns and vocal qualities that are remarkably difficult to fake convincingly. The duration, intensity, and musicality of laughter all carry meaning. A brief, polite chuckle conveys very different information than a long, helpless belly laugh. Nervous laughter emerges in uncomfortable situations, serving as a self-soothing mechanism and a social signal that helps diffuse tension. Sighs, gasps, groans, and other non-verbal vocalizations punctuate speech and carry emotional weight. A sigh can express frustration, relief, fatigue, or resignation depending on its acoustic qualities and context. A gasp signals surprise or shock. A groan indicates discomfort, disappointment, or physical strain. These vocalizations bypass the linguistic processing centers of the brain, communicating visceral responses more directly than words ever could. The phenomenon of vocal fry, a creaky popping quality at the bottom of the vocal range, has become increasingly common in contemporary speech, particularly among young women in Western cultures. While some view it as affecting or annoying, linguists note that vocal fry serves communicative functions, often marking authority, finality, or casualness. Like other aspects of vocal production, it can be both consciously controlled and unconsciously produced depending on context and intent. Emotional contagion through voice represents a powerful but often overlooked phenomenon. When we hear someone speak with genuine emotion, neural pathways in our brains activate as if we were experiencing that emotion ourselves. An enthusiastic voice can energize listeners. A calm voice can soothe them. An angry voice can provoke anxiety even if the anger isn't directed at the listener. This emotional transmission happens below the level of conscious processing, affecting us before we've even fully comprehended the words being spoken. crying provides perhaps the most primal example of vocal communication, beginning in infancy before language develops. The quality of an infant's cry, its pitch, urgency, and pattern allows caregivers to distinguish between hunger, pain, discomfort, and fatigue with surprising accuracy. This vocal communication system, evolutionarily ancient, ensures that pre-verbal humans can still convey their needs effectively. Even silence speaks. The pregnant pause, the deliberate refusal to respond, the comfortable quiet between friends. These absences of sound carry meaning too. Silence can convey contemplation, agreement, disapproval, or intimacy depending on context and relationship. Learning when to be silent is as important to communication as learning what to say. Your voice betrays you constantly, revealing emotions you might wish to conceal, broadcasting stress you're trying to hide, communicating warmth or coldness independent of your words. It operates partially under conscious control. You can modulate your tone, adjust your volume, carefully craft your prosody. But the autonomic nervous system maintains its influence, ensuring that your true emotional state bleeds through in ways subtle enough that you might not notice, but significant enough that sensitive listeners pick up on the signals. The Meunj, the autonomic nervous system's involuntary revelations beneath all your conscious efforts at communication. Your autonomic nervous system operates like an honest witness, broadcasting signals you cannot fully control. This ancient part of your nervous system, responsible for regulating heart rate, breathing, digestion, and countless other automatic functions, responds instantaneously to emotional stimuli, producing physical changes that reveal your inner state to anyone who knows what to observe. Blushing represents one of the most visible autonomic responses, a sudden rush of blood to the facial skin that creates obvious redness. This happens when you experience embarrassment, shame, romantic attraction, or intense self-consciousness. The sympathetic nervous system triggers vasodilation in facial blood vessels, flooding the skin with blood in a response that seems counterproductive from a survival perspective. Why would evolution preserve a mechanism that makes our discomfort so visible to others? Researchers suggest that blushing might serve as an appeasement signal, a non-verbal apology or acknowledgement of social transgression. When we blush, we demonstrate that we recognize we violated a social norm and feel remorse. This visible display of embarrassment might actually help restore social standing by showing others that we understand and care about social rules. The person who blushes after a social misstep shows awareness and concern, potentially earning forgiveness more readily than someone who appears unbothered. Interestingly, while we can sometimes trigger a blush through deliberate thought about embarrassing situations, we cannot stop one once it starts. The autonomic system insists on having its say. Psychologists have noted that the capacity to blush reflects sophisticated social awareness. To feel embarrassed enough to blush requires understanding how others perceive you, recognizing social norms, and caring about your standing in others' eyes. Young children don't blush because they haven't yet developed this level of social self-consciousness. The emergence of blushing in later childhood marks development of mature social cognition. Individuals who never blush might lack this social sensitivity, potentially explaining why blushing, despite its discomfort, persists evolutionarily. It signals pro-social concern for others' judgments. Sweating increases during stress, fear, or strong emotion due to activation of the sympathetic nervous system, while thermoregulatory sweating helps cool the body during physical exertion. Emotional sweating serves a different function entirely. It primarily affects the palms, soles of feet, and underarms, locations rich in eccrine sweat glands that respond to psychological rather than thermal stimuli. This emotional sweating likely evolved to improve grip during threatening situations, making it easier to climb, grasp weapons, or hold onto tools. The moist palms that evolution designed for enhanced grip in dangerous moments now primarily serve to betray our anxiety during job interviews, first dates, and stressful social encounters. The pattern of emotional sweating differs noticeably from heat-related sweating. Stress sweat appears more suddenly, often before any elevation in body temperature occurs. It tends to smell different too. Emotional sweat contains more proteins and lipids that bacteria on the skin metabolize, creating the characteristic odor of nervous perspiration. This odor may itself serve communicative functions, potentially signaling stress to others and triggering heightened alertness in social groups facing shared threats. Interestingly, the relationship between sweating and emotion works bidirectionally. Just as stress triggers sweating, experimental induction of palm moisture through artificial means can actually increase reported anxiety levels, suggesting the physical sensation of sweaty palms feeds back to amplify emotional experience. The body and mind remain in constant dialogue, each influencing the other through countless subtle channels. The pupils of your eyes dilate and constrict automatically in response to both light levels and emotional state. Attraction, interest, arousal, and cognitive effort all trigger pupil dilation, as does simple exposure to something we find aesthetically pleasing. Fear and surprise produce the same response. This happens because the sympathetic nervous system, activated during emotional arousal, overrides normal, light-responsive pupil control. The dilated pupils allow maximum light entry, enhancing visual acuity during moments of heightened attention or potential threat. Research has shown that dilated pupils themselves can trigger attraction in others, creating feedback loops of mutual interest. When someone's pupils dilate while looking at you, you unconsciously find them more attractive, which dilates your own pupils, which further increases their attraction to you. This subtle dance happens entirely below conscious awareness, yet profoundly influences social and romantic connection. Skilled poker players and salespeople learn to watch for pupil changes as indicators of genuine interest or concern, though the response is so quick and subtle that most people don't consciously notice these fluctuations. The pupillary response to cognitive effort, pupils dilating during difficult mental tasks, provides an unusually direct window into cognitive load. As problems become more challenging, pupils expand proportionally to the mental resources being devoted to solving them. This response is so reliable that researchers use pupillometry to measure cognitive demand in various tasks. When pupils remain constricted during supposedly difficult work, it suggests minimal actual engagement with the task. Your heart rate shifts constantly throughout the day, accelerating during stress and decelerating during relaxation. But it also responds to social and emotional stimuli in revealing ways. When lying or feeling guilty, heart rate typically increases due to the stress response triggered by potential consequences of discovery. This cardiovascular acceleration can be detected through various means, from pulse monitoring to subtle observations of flushing or breathing changes that accompany increased heart activity. When we feel calm and connected with someone, our heart rates can actually synchronize over time, a phenomenon observed between close friends, romantic partners, and parents with their children. Musicians playing together show heart rate synchronization. Therapists and clients sometimes demonstrate this coordination. The mechanism appears to involve mutual influence through shared breathing patterns, emotional contagion, and mirroring of subtle body movements, all creating a physiological alignment that reinforces psychological connection. Heart rate variability, the variation in time between consecutive heartbeats, provides another rich source of information about autonomic state. High variability generally indicates a healthy, flexible nervous system, capable of adapting rapidly to changing demands. Low variability suggests a system under chronic stress, locked in defensive mode, with reduced capacity for nuanced response. This measure has become increasingly important in health monitoring, with research linking reduced heart rate variability to various stress-related conditions, from cardiovascular disease to depression to chronic pain. Breathing pattern changes dramatically with emotional state, providing one of the most accessible windows into autonomic nervous system activity. Anxiety produces rapid, shallow breathing, concentrated in the upper chest as the body prepares for threat. Quick exchanges of air that prioritize speed over efficiency. This hyperventilation pattern emerged evolutionarily to support rapid physical action, flooding the blood with oxygen for fighting or fleeing. In modern contexts, where physical escape isn't possible or appropriate, this breathing pattern persists, creating a feedback loop where rapid breathing reinforces anxiety, which further accelerates breathing. Sadness slows and deepens breathing, shifting the pattern toward the abdomen and creating longer, more complete breaths. This respiratory slowing may reflect the energy conservation associated with depressive withdrawal. When threat feels overwhelming rather than manageable, the nervous system sometimes downregulates, conserving resources until conditions improve. Sighing, characteristic of sadness, serves a physiological function too, periodically re-inflating collapsed lung tissue through a very deep breath, preventing atelectasis during extended periods of shallow breathing. Anger makes breathing forceful and irregular, with sharp inhalations and emphatic exhalations that support aggressive vocalizations. The breathing becomes louder, more audible, signaling arousal to others even before words or actions convey hostility. In confrontational situations, people often synchronize their breathing adversarially, matching each other's intensity but not necessarily timing, creating an escalatory dynamic where each party's physiological arousal feeds the others. These respiratory changes are so closely tied to emotion that deliberately altering breathing pattern can actually shift emotional state, a principle exploited by meditation and breathing exercises. Slow, deep, diaphragmatic breathing activates the parasympathetic nervous system, triggering relaxation responses even during stressful situations. This works because the vagus nerve, which monitors breathing, provides direct feedback to brain regions controlling emotional state. Controlled breathing essentially hacks this system, using voluntary action to influence involuntary processes. The breath serves as a bridge between conscious and unconscious, between voluntary and involuntary control. We can deliberately control breathing more easily than we can control heart rate, blood pressure, or digestive function, yet breathing also continues automatically when we don't think about it. This dual control makes breath a particularly valuable tool for influencing autonomic state. It provides a handle we can grasp to steer systems normally beyond conscious reach. Goosebumps, that prickling sensation when small muscles at the base of hair follicles contract, represent an evolutionary vestige that persists as an emotional signal. In our furrier ancestors, this piloerection made the animal appear larger and more threatening, useful during conflict. It also trapped air near the skin, providing insulation in cold weather. Today, we experience goosebumps during cold, fear, and strong emotional experiences, moments of awe, powerful music, profound connection. The sensation marks moments when we're deeply affected, a physical manifestation of emotional significance. Gut feelings have a physical basis. When stressed or anxious, the sympathetic nervous system diverts blood flow away from the digestive system toward major muscle groups, creating that characteristic butterfly sensation. The enteric nervous system, sometimes called the second brain, contains more neurons than the spinal cord and communicates constantly with the brain through the vagus nerve. This gut-brain axis means that emotional states directly affect digestive function, and gut health influences mood and anxiety levels. The body is truly interconnected in ways we're only beginning to fully understand. Muscle tension increases automatically during stress, preparing the body for action. Jaw clenching, shoulder raising, hand gripping, and postural bracing all happen without conscious input when we feel threatened or under pressure. This tension, when chronic, manifests as headaches, back pain, and a host of stress-related physical complaints. The body prepares for battles that never come, maintaining a state of readiness that exhausts resources and creates discomfort. Trembling or shaking occurs when the stress response floods the body with adrenaline, priming muscles for action. When that action doesn't come, when we must remain still during a frightening or emotionally intense moment, the excess energy manifests as visible tremors. Hands shake, legs quiver, voice wavers. These involuntary movements broadcast our internal state clearly. Another example of the autonomic system revealing what the conscious mind might wish to conceal. Facial flushing extends beyond blushing to include general redness or paleness. During emotional arousal, blood flow patterns shift, sometimes creating visible changes in skin tone across the face, neck, and chest. Some people develop red blotches on their neck and upper chest when stressed, an autonomic response that's particularly difficult to hide. Conversely, fear or shock can cause blood to drain from the face, creating visible pallor that signals distress. The startle response represents one of the most rapid autonomic reactions, a coordinated pattern of muscle contractions that happens within milliseconds of an unexpected stimulus. Eyes blink shut, shoulders raise, head pulls back. This whole body flinch protects vital areas and prepares for potential threat. The intensity and duration of the startle response correlate with anxiety levels. Highly anxious individuals show exaggerated startle responses, their bodies constantly on high alert. Crying, while partly under voluntary control, has strong automatic components. Tears emerge from the lacrimal glands in response to emotion, creating visible wetness that's extremely difficult to fake convincingly. The specific pattern of facial muscle contraction during genuine crying, combined with vocal changes and breathing irregularities, creates a signal that observers instinctively recognize as authentic. We can sometimes hold back tears through conscious effort, but the body insists on producing them when emotion reaches a certain threshold. These autonomic signals create challenges for anyone attempting to conceal their true feelings. While you might control your facial expression and choose your words carefully, your pupils continue to dilate with stress. Your palms continue to sweat with nervousness. Your heart rate continues to surge with emotion. The autonomic nervous system, evolved to prepare your body for survival threats, continues operating according to its ancient programming, broadcasting your internal state through channels you cannot fully control. This honest signaling serves important social functions. It allows others to detect genuine emotion, helping them respond appropriately. It makes deception difficult, maintaining a baseline of honesty in social interactions. It provides feedback about our own emotional state. Sometimes we don't fully realize how stressed or affected we are until we notice our own autonomic responses. The body keeps the score, remembering and revealing what the conscious mind might prefer to forget or hide. The chemistry of connection. Beyond visible body language and vocal signals, we communicate through channels so subtle that we're only beginning to understand their full implications. Chemical communication through pheromones, hormones, and other molecular messengers represents perhaps the most primal form of body language, a system of signaling that predates not just language, but even complex nervous systems. Pheromones are chemical compounds released by organisms that affect the behavior or physiology of others of the same species. In insects and many mammals, pheromones play clear, well-documented roles in mating, territory marking, danger signaling, and social organization. A queen bee releases pheromones that suppress reproductive development in worker bees. Moths can detect potential mates from miles away through pheromone trails. Ants lay pheromone paths that guide colony members to food sources. In humans, however, the story is more complex and contentious. While we possess a vomeronasal organ during fetal development, this structure, which detects pheromones in many animals, typically doesn't remain functional in human adults. Yet research suggests we do respond to chemical signals in ways we don't consciously perceive. Studies have shown that the smell of fear, sweat, produced during stress, triggers anxiety responses in others who smell it, even when they can't consciously detect anything unusual. The scent of a partner's worn clothing can reduce stress levels and improve sleep quality. Infants recognize their mother's unique scent within days of birth, and mothers can identify their baby by smell alone. These findings suggest that chemical communication operates in humans, perhaps not through a dedicated pheromone system, but through our standard olfactory pathways connected to emotional and memory centers in the brain. Beyond potential pheromones, the hormones coursing through your bloodstream constantly influence how you interact with and perceive others. Oxytocin, often called the bonding hormone, increases during positive social interactions, physical touch, and moments of connection. It promotes trust, reduces anxiety, and strengthens feelings of attachment between people. The surge of oxytocin during childbirth and breastfeeding helps establish the mother-infant bond. The same hormone facilitates romantic attachment, friendship, and even business trust. Interestingly, oxytocin also has a dark side. While it promotes bonding with in-group members, it can increase suspicion and even hostility toward out-group members. This dual nature suggests oxytocin evolved not just to promote indiscriminate love, but to strengthen tribal bonds in a world where distinguishing friend from foe carried survival implications. Your body's chemical signals don't just draw you toward everyone equally. They help you navigate complex social landscapes where not everyone has your best interests at heart. Testosterone levels fluctuate throughout the day and in response to social situations affecting and reflecting dominance behaviors. Levels typically rise before competitions and increase further after victories, while declining after defeats. This creates feedback loops where hormonal state influences confidence and aggression, which affects social outcomes, which in turn shifts hormonal state. Athletes preparing for competition show testosterone increases that may enhance performance, focus, and competitive drive. Cortisol, the primary stress hormone, floods your system during threatening or challenging situations, mobilizing energy and focusing attention. Chronic elevated cortisol has numerous negative health effects, but in the short term, cortisol-mediated stress responses have kept humans alive through countless challenges. Interestingly, cortisol levels drop significantly during positive social interactions, massage, and activities like petting dogs or laughing with friends. Your body quite literally relaxes its chemical defenses when it feels safe and connected. Endorphins, the body's natural painkillers, release during exercise, laughter, music, and social bonding. These molecules create feelings of euphoria and pleasure, rewarding behaviors that evolution has deemed important, physical activity that maintains fitness, social connections that provide survival advantages, experiences that build group cohesion. When you laugh so hard your face hurts or dance until you're dizzy with joy, endorphins are washing through your system, chemically reinforcing the value of these activities. Dopamine, central to motivation and reward, surges when we experience or anticipate pleasure. Social interactions trigger dopamine release, particularly novel or exciting encounters. This is why new relationships feel so intoxicating. Your brain is literally flooding with feel-good chemicals. Dopamine also drives seeking behavior, making us crave connection, novelty, and reward. Understanding this chemical dimension of social motivation helps explain why loneliness feels so painful. We're literally being denied a crucial chemical reward system. The gut microbiome, the vast community of bacteria and other organisms living in your digestive system, influences the production of many neurotransmitters that affect mood and behavior. The gut as a whole produces about 90 to 95% of the body's serotonin, a key regulator of mood, though most of this production happens in specialized gut cells called enterochromaffin cells. Research has shown that certain gut bacteria help stimulate these cells to produce serotonin, essentially acting as facilitators rather than direct manufacturers. Gut bacteria also produce GABA, which reduces anxiety and creates short-chain fatty acids that influence brain function. This intimate relationship between gut flora and mental state means that what you eat, which feeds or starves various bacterial populations, directly affects your emotional state, and by extension, how you interact with others. Even diet influences body chemistry in ways that affect social behavior. Foods rich in tryptophan boost serotonin production, potentially improving mood. Complex carbohydrates support stable blood sugar, preventing mood swings. Omega-3 fatty acids influence brain chemistry in ways that may reduce depression and anxiety. We are what we eat, quite literally, at a chemical level that shapes how we feel and behave. Adrenaline, released during excitement or stress, creates the racing heart and heightened alertness we associate with intense experiences. This is the hormone behind love at first sight, feelings, nervousness before a first date, and the exhilaration of novel experiences. When someone makes your heart race, that's not metaphor. It's adrenaline creating a literal cardiovascular response that your brain interprets as attraction or excitement. The timing and interplay of these various chemical messengers create the rich emotional landscape of human experience. Oxytocin might promote bonding, while dopamine drives seeking and reward, while endorphins create pleasure, while cortisol adds an edge of vigilance. The specific cocktail present at any moment shapes not just how you feel, but how you perceive and respond to others. Your chemistry is constantly in conversation with others' chemistry, creating a dance of mutual influence that happens entirely beneath conscious awareness. This chemical dimension of body language reminds us that communication happens at every level of biological organization, from molecular signals passing between cells, to pheromones wafting through air to hormones flooding the bloodstream. We are always broadcasting and receiving chemical information. Our bodies speak in molecules as fluently as they speak in gestures, perhaps even more honestly, since chemical signals respond to genuine internal states rather than social performance. Reading the hidden messages, understanding the various channels through which the body communicates is one thing. Actually reading these signals accurately in real time is quite another. The human body constantly generates a blizzard of signals, facial expressions, gestures, vocal qualities, physiological changes, creating a communication environment far richer and more complex than language alone could convey. Learning to navigate this landscape requires understanding not just individual signals, but how they cluster together and interact with context. The first principle of accurate body language reading is congruence. When someone's verbal message, facial expression, vocal tone, gestures, and physiological signals all align, communication is clear and trustworthy. But when these channels conflict, when someone says, "I'm fine," with a tense face, closed posture, and strained voice, the nonverbal signals typically reveal the truth. Our brains evolved to detect these incongruencies because survival often depended on distinguishing genuine from deceptive signals. The second principle is clusters. A single gesture or expression, isolated from context, rarely tells a complete story. Someone might cross their arms because they disagree, because they're cold, because they're simply comfortable that way, or because they're unconsciously mirroring someone else. Reading body language requires observing multiple signals simultaneously and noticing patterns. If crossed arms appear alongside a furrowed brow, compressed lips, lean back, and tension in the jaw, the cluster suggests disagreement or defensiveness. Context matters enormously. The third principle is baseline awareness. Everyone has their own normal patterns of behavior, their personal communication style. Some people naturally use expansive gestures, Others are more contained. Some make intense eye contact. Others look away frequently. To detect meaningful changes in someone's body language, you must first understand their baseline. Deviation from baseline is where the most valuable information lies. When a typically calm person suddenly becomes fidgety, when someone who usually makes strong eye contact begins avoiding your gaze, when a relaxed person's shoulders tense up, these changes signal something significant. Cultural context shapes body language interpretation profoundly. As we've noted, many gestures carry different meanings across cultures. What's considered respectful eye contact in one cultural context might seem aggressive or inappropriate in another. Personal space preferences vary dramatically by culture. Touch norms differ. Even facial expressions, while largely universal in basic form, get regulated and modified by cultural display rules about which emotions are appropriate to show in which situations. Reading body language cross-culturally requires humility and awareness that your interpretations might not apply universally. Timing and sequence matter too. In authentic emotional expressions, different components happen in a predictable order. A genuine smile, for instance, builds gradually, reaches a peak, and declines, with the entire sequence happening smoothly over 1 to 4 seconds. The eyes crinkle before or simultaneously with the mouth movement. In contrast, fake smiles often appear abruptly, lack the eye component, and disappear quickly with little transition. Micro-expressions, by definition, occur before the person can create a controlled expression. Understanding these temporal patterns helps distinguish genuine from performed emotion. Stress and comfort indicators provide particularly useful information. Certain behaviors reliably indicate psychological or physical comfort. Open postures, relaxed muscle tension, genuine smiles, easy breathing, fluid movement, appropriate space between self and others. Conversely, stress indicators include closed postures, muscle tension, forced expressions, shallow or irregular breathing, fidgeting, and invasion of or retreat from personal space. Reading someone's comfort level gives you crucial feedback about how an interaction is progressing. Self-soothing behaviors deserve special attention. When stressed or uncomfortable, people engage in various pacifying actions that help regulate their nervous system. Rubbing the neck, touching the face, stroking the hair, massaging the hands, adjusting clothing. These adapters indicate the person is experiencing some form of distress and attempting to self-comfort. The frequency and intensity of these behaviors correlates with stress levels. Someone rubbing their neck repeatedly while answering questions is broadcasting discomfort, even if their words remain composed. Barriers and distancing behaviors reveal psychological states too. When uncomfortable, people create physical barriers between themselves and the source of discomfort. Crossing arms or legs, holding objects in front of their torso, leaning away, turning the body at an angle rather than facing directly. These behaviors represent unconscious attempts to protect oneself or create distance. Conversely, removing barriers, leaning in, and opening the body towards someone signals interest and comfort. Eye behaviors provide particularly rich information. Beyond the basic pattern of eye contact, consider where eyes move. Looking up and to the right, for most people, typically accompanies visual imagination, while up and to the left involves visual memory. These patterns appear during normal thought processes, not just deception. Rapid eye blinking increases during stress, Prolonged closing of the eyes or covering them with hands suggests a desire to shut out disturbing information. The direction of gaze tells you what commands someone's attention. People look at what interests or concerns them. Feet and legs, being the body parts least under conscious control, often reveal information that the more carefully monitored face and hands conceal. Feet pointing toward the door during a conversation might indicate a desire to leave. Legs crossed away from someone might signal discomfort. Jiggling feet or bouncing knees betrays nervous energy or impatience. Because people pay less attention to controlling their lower bodies, these regions often leak information more honestly than upper body or face. The voice provides multiple channels of information beyond words. Pitch, volume, rate, pauses, timbre, breathing patterns, laughs, sighs. All these carry meaning. But voice is also one of the hardest channels to control completely. Stress reliably affects voice quality, often creating tightness or slight trembling that's difficult to eliminate through conscious effort. Learning to hear these vocal cues requires attentive listening that goes beyond words to the qualities of sound itself. Synchrony and mirroring deserve attention too. When people feel rapport, their bodies naturally synchronize, matching postures, gesturing in similar ways, even breathing at similar rates. This happens automatically between friends, romantic partners, and people establishing connection. When this synchrony breaks down, when one person's body language suddenly diverges sharply from the other's, it often signals discomfort, disagreement, or emotional distance. Conversely, deliberate mirroring can help establish rapport, though it must be subtle to avoid seeming manipulative. Contextual awareness is crucial. A person's body language in a job interview differs from their body language at a party with close friends. Stress, formality, familiarity, power dynamics, and countless other contextual factors shape how people present themselves physically. What appears to be nervousness in one context might simply be appropriate formality in another. Always consider the situation when interpreting body language signals. Personal factors like physical limitations, neurological conditions, cultural background, and individual personality all influence body language. Some people naturally maintain less eye contact due to autism spectrum conditions rather than discomfort or deception. Others have physical conditions that affect posture or movement. Cultural background shapes which body language patterns feel natural and appropriate. Individual personality traits like introversion or extroversion influence characteristic behavior patterns. Responsible body language reading requires accounting for these individual differences. Caution about overinterpretation is warranted. Body language provides clues and insights, not certainties. No single gesture definitively proves lying, attraction, anger, or any other state. Even clusters of behaviors allow only probabilistic conclusions. The field of body language has been plagued by overstated claims and pseudoscientific certainty. Responsible interpretation requires humility, recognition of ambiguity, and willingness to revise conclusions as additional information emerges. Perhaps most importantly, remember that body language interpretation works best when combined with other information sources. The content of what people say, your knowledge of them and their circumstances, the broader context of the interaction. Body language enriches and sometimes contradicts verbal communication, but it works most powerfully in concert with language rather than replacement of it. Used thoughtfully, attention to body language can deepen understanding and strengthen connection. Used carelessly or manipulatively, it can lead to misunderstanding and harm. When communication goes wrong, for all its sophistication and redundancy, the body's communication systems can fail in various ways. Understanding these failures illuminates both the complexity of normal communication and the challenges faced by those whose bodies don't speak the expected language. These conditions also reveal how deeply we rely on body language to navigate social interaction. Autism spectrum disorders fundamentally affect how people process and produce social signals. Individuals with autism often find typical body language confusing or overwhelming. They may struggle to interpret facial expressions, miss subtle social cues, or misread tone of voice. Reciprocally, their own body language may not follow typical patterns. Eye contact might feel uncomfortable or meaningless. Facial expressions might not match internal emotional states, or vocal inflection might remain flat, regardless of feeling. This creates a bidirectional communication challenge where neurotypical people misinterpret autistic individuals, just as autistic individuals struggle to read neurotypical signals. The social challenges autism creates stem less from any deficit in autistic individuals themselves and more from a mismatch between their natural communication style and society's expectations. When autistic people communicate with each other, they often report feeling more comfortable and understood. This suggests the problem lies not in autism, but in the gap between different communication styles. Understanding this helps shift perspective from viewing autism as broken communication to recognizing it as different communication that deserves accommodation and respect. Parkinson's disease affects body language in particularly challenging ways. The condition causes muscle rigidity, tremors, and reduction in spontaneous movement, creating what's sometimes called a masked face, where facial expressions become limited or absent. People with Parkinson's may feel emotions just as intensely as before, but struggle to display them physically. Their voice may lose inflection, becoming monotonous despite rich internal experience. Their posture often becomes stooped and their gait shuffling, completely independent of their actual confidence or mood. This disconnect between internal state and external expression creates profound social difficulties. Others may perceive someone with Parkinson's as depressed, disinterested, or mentally impaired based solely on their limited physical expressiveness, even when their cognitive abilities remain fully intact. The person with Parkinson's experiences the frustration of feeling emotions they cannot adequately display, of being misunderstood not through any failing of their own, but through their body's inability to speak the typical language. Stroke damage to specific brain regions can create various communication impairments. Damage to motor cortex areas controlling facial muscles may eliminate expression on one side of the face while leaving the other functioning normally. Damage to language areas may preserve understanding of body language while eliminating ability to produce or comprehend speech. Some stroke survivors can gesture, mime, and express through facial expressions even when words fail them, revealing how distinct these communication systems are neurologically. Conversely, some right hemisphere strokes impair body language interpretation while leaving language relatively intact. Affected individuals may understand words perfectly, but miss sarcasm conveyed through tone, fail to detect emotional cues from facial expressions, or not notice that someone is upset based on posture and gesture. This reveals how much social information we normally extract from non-verbal channels, and how challenging social interaction becomes when those channels are disrupted. Social anxiety disorder involves hypervigilance to perceived negative evaluation, often expressed through and exacerbated by body language concerns. Someone with social anxiety might become acutely self-conscious about their own body language, leading to stiff, unnatural movement and expression. This self-monitoring ironically makes social interaction more difficult and may create the very impression of awkwardness they fear. They may also overinterpret others' body language, seeing rejection or judgment in neutral expressions and leading to avoidance of social situations. Depression profoundly affects body language, creating characteristic patterns of slumped posture, reduced facial expression, minimal gesturing, slow movement, and averted gaze. The physical heaviness many describe during depression manifests literally in how the body moves and positions itself. Voice becomes flat and quiet. Response time slows. This physical expression of depression both reflects and potentially reinforces the internal experience, as bodily expression of sadness can deepen sad feelings through embodied cognition feedback loops. Schizophrenia spectrum disorders can disrupt body language in various ways. Catatonia, in its severe form, involves near-complete reduction of movement and expression. Negative symptoms can flatten affect, reducing emotional expression despite preserved internal feeling. Disorganized behavior may produce body language that seems random or inappropriate to context. Conversely, during paranoid states, hypervigilance and suspicion may manifest as tense, guarded body language even in safe situations. Traumatic brain injuries affecting frontal lobe regions can impair the social cognition necessary for appropriate body language production. Survivors may lose subtle control over their expressions and gestures, becoming more emotionally labile or producing body language that seems inappropriate to context. Damage to mirror neuron systems may affect empathy and social synchrony. The specific effects depend entirely on which brain regions sustain damage, illustrating how distributed and complex the neural systems supporting body language truly are. Chronic pain conditions alter body language in characteristic ways. Pain creates guarding behaviors, protective positioning, reduced movement range, tense postures designed to prevent or minimize hurt. Facial expressions of pain, while partly controllable, reliably involve specific muscle contractions around the eyes and mouth that observers can detect even when someone tries to conceal their discomfort. Chronic pain can create perpetually tense, closed body language that affects how others perceive and interact with the person. Selective mutism, an anxiety disorder most common in children, involves inability to speak in certain social situations, despite normal speech ability in comfortable settings. Children with selective mutism typically rely heavily on nonverbal communication, gestures, facial expressions, body language, to express themselves when speech becomes impossible. This challenges the notion that verbal language is primary, showing how effectively non-verbal channels can communicate when verbal channels are blocked. Facial paralysis from conditions like Bell's palsy eliminates expression on affected portions of the face, creating communication challenges similar to those seen in Parkinson's disease. The person feels emotions normally, but cannot display them through the paralyzed region. Others may misread their emotional state or feel uncomfortable with the asymmetry. Like Parkinson's, facial paralysis reveals how much we rely on facial feedback, both to express ourselves and to read others. Non-verbal learning disabilities specifically impair body language comprehension and production while leaving verbal abilities intact or even superior. Affected individuals struggle to read social cues, interpret tone, understand personal space, or produce appropriate non-verbal behavior despite high verbal intelligence. This again reveals the neurological distinctness of these systems and how much we rely on non-verbal channels for successful social interaction. These various conditions illustrate several important principles. First, body language and verbal language rely on partly distinct neurological systems that can be impaired separately. Second, successful communication requires coordinated functioning of multiple systems. When any component fails, the whole suffers. Third, much of the disability in these conditions comes from mismatches between affected individuals' communication style and social expectations rather than from absolute inability to communicate. Fourth, body language profoundly affects social interaction in ways we often don't fully appreciate until it's disrupted. Understanding these conditions should increase compassion for those whose bodies don't speak the typical language. It should also increase awareness of how much communication happens through channels we take for granted. When we encounter someone whose body language seems off or absent, the issue may lie not in their willingness to communicate, but in their ability to use typical channels. Adjusting expectations and creating accommodations allows these individuals to connect using whatever communication channels remain available to them. The future of understanding human communication. As technology advances, our ability to detect, measure, and interpret body language is expanding in ways that would have seemed impossible just decades ago. These developments promise both exciting possibilities and serious ethical challenges as we venture into unprecedented territory in understanding the hidden language of the human body. Artificial intelligence and machine learning now enable computers to recognize facial expressions, analyze vocal prosody, and detect emotional states from physiological signals with increasing accuracy. Security systems scan faces for threatening expressions. Marketing firms analyze consumers' micro-reactions to advertisements. Therapeutic applications use AI to detect early signs of depression or anxiety from speech patterns. These technologies extend far beyond human perceptual abilities in some ways, processing subtle patterns across millions of faces or voices, detecting micro-changes too brief for human awareness, correlating body language signals with outcomes at population scale. Wearable sensors now track heart rate variability, skin conductance, movement patterns, and sleep quality, generating continuous streams of physiological data that reveal stress levels, emotional states, and health status. Future devices will likely measure cortisol, detect chemical signatures in breath or sweat, and provide real-time feedback about autonomic nervous system activity. This creates possibilities for immediate intervention. Imagine a device that detects rising anxiety and prompts breathing exercises before panic develops, or one that warns you that you're showing physiological signs of burnout before you consciously feel it. Virtual reality and augmented reality technologies are beginning to incorporate body language recognition, allowing systems to respond to users' emotional states and non-verbal cues A virtual therapy session might adapt based on detecting patient stress or disengagement. Educational software could adjust difficulty based on learner frustration. Social VR might use avatar body language to create more authentic feeling interactions. As these technologies improve, the boundary between physical and virtual social interaction will continue blurring. Brain-computer interfaces may eventually allow direct neural communication that bypasses body language entirely. Thoughts and emotions transmitted from brain to brain without the intermediary of physical expression. While this remains speculative, early research shows promise in allowing paralyzed individuals to control devices with thought, and extension to communication seems conceivable. Yet, even as we develop these futuristic technologies, we're simultaneously rediscovering the importance of ancient forms of communication, touch, presence, embodied interaction that our video-mediated culture often neglects. Medical applications of body language analysis are advancing rapidly. Clinicians are using automated facial expression analysis to detect pain in nonverbal patients, monitor depression treatment response, or identify early signs of neurodegenerative disease. Wearable devices track movement patterns that might indicate Parkinson's progression or fall risk in elderly patients. Voice analysis algorithms screen for mental health conditions. These tools promise earlier detection and more objective monitoring than traditional clinical observation alone can provide. However, these technological advances raise profound ethical questions. Privacy concerns loom large. If cameras can detect our emotional states, who has the right to that information? Should employers be able to monitor workers' stress levels? Should governments scan crowds for signs of criminal intent? Should advertisers be allowed to measure emotional reactions to manipulate purchasing decisions? The invisible nature of body language makes it particularly vulnerable to covert surveillance that people might not even know is happening. Consent becomes complicated when the information being gathered is produced unconsciously. You can choose whether to answer a question, but you cannot choose whether to display micro-expressions or physiological stress responses. If these involuntary signals can be detected and interpreted by technology, have we lost control over our own communication? Do we have the right to keep our body signals private? Or does the mere act of existing in public spaces consent to having those signals read? Accuracy concerns persist too. While AI systems show impressive performance in laboratory conditions, real-world body language remains complex and context-dependent in ways that challenge algorithmic interpretation. A system that mistakes nervousness for deception, cultural differences for dishonesty, or medical conditions for emotional states could cause tremendous harm. Over-reliance on automated body language analysis might create a false sense of certainty about internal states that remain fundamentally ambiguous. Bias in these systems represents another critical challenge. AI learns from training data, and if that data reflects the biases of its creators or contains unrepresentative samples, the resulting systems will perpetuate and potentially amplify those biases. If facial recognition systems are trained primarily on one ethnic group, they perform poorly on others. If emotion detection algorithms are built using Western emotional expressions as the standard, they may misclassify expressions from other cultures. These technical problems have social justice implications. Potential for manipulation grows as understanding of body language deepens. If we know which signals trigger trust, attraction, or compliance, these signals can be engineered to manipulate. Some already worry about social engineering attacks that exploit body language to extract information or influence behavior. Deepfake video technology can now create convincing fake body language, undermining the assumption that seeing someone's physical expression guarantees authenticity. As technology for reading body language improves, so does technology for faking it. Yet these advances also offer genuine benefits. They promise better healthcare through earlier detection of illness and more objective monitoring of treatment. They could enhance education by allowing systems to adapt to students' engagement and comprehension in real time. They might improve accessibility for people with communication impairments, creating systems that translate their nonverbal signals into forms others can more easily understand. They could deepen empathy by making invisible emotional states more visible and fostering greater awareness of others' experiences. The key lies in thoughtful development and deployment of these technologies, with robust ethical frameworks, strong privacy protections, and genuine input from diverse stakeholders. We need clear policies about consent, data ownership, and appropriate uses. We need continued research into cross-cultural differences and individual variation. We need healthy skepticism about claims of certainty. Body language provides probabilistic information, not absolute truth, and technology should be positioned accordingly. Perhaps most importantly, we need to maintain human wisdom alongside technological capability. Understanding body language requires not just pattern detection, but empathy, context, sensitivity, cultural awareness, and recognition of ambiguity. These deeply human capabilities should guide and constrain technological applications rather than being replaced by them. The goal should be augmenting human understanding, not eliminating human judgment from the equation. As we move forward, the challenge will be harnessing the benefits of these advancing technologies while protecting the values we hold dear: privacy, autonomy, dignity, authentic human connection. The hidden language of the human body has been speaking for millions of years, long before we had the technology to decode it systematically. Now that we are developing that capability, we must decide how to use it wisely. The development and evolution of body language. Understanding the hidden language of the human body requires looking back through deep time to the evolutionary pressures and developmental stages that shaped these communication systems. Body language didn't emerge fully formed. It evolved gradually over millions of years, refined by the relentless pressures of survival, reproduction, and social coordination. In our earliest ancestors, body language likely served primarily threat detection and dominance assertion functions. Before complex social groups, before cooperative hunting, before language, primates needed to quickly assess whether another individual posed a threat or an opportunity. A direct stare might signal aggression. Bared teeth could indicate either threat or submission, depending on context and accompanying signals. Posture communicated size and physical capability, crucial information in assessing potential conflicts. As our ancestors became more social, body language grew more sophisticated. Living in groups created new communicative demands, coordinating hunts, maintaining alliances, negotiating status hierarchies, identifying reliable partners. The individuals best able to send and read these signals enjoyed substantial advantages. They formed stronger alliances, avoided unnecessary conflicts, found better mates, and raised offspring more successfully. Over countless generations, natural selection favored increasingly refined body language systems. Facial expressions evolved particularly rich complexity in primates, especially humans, likely because faces provided high-resolution displays visible from a distance. The human face, with its minimal fur and highly mobile muscles, became an extraordinary canvas for emotional broadcasting. Unlike many mammals whose faces remain relatively static, humans can produce thousands of distinct expressions, broadcasting internal states with remarkable precision. This capacity likely co-evolved with increasingly complex social groups, where understanding others' intentions and emotions provided crucial advantages. The evolution of white sclera in human eyes, unique among primates, illustrates how body language shaped our physical form. Most primates have dark sclera that make it difficult for others to determine gaze direction, perhaps advantageous when concealing attention is valuable. Humans evolved conspicuous white sclera that make gaze direction immediately obvious to observers. This suggests that being able to follow others' attention and coordinate focus on shared objects provided such strong advantages that we sacrificed gaze concealment for gaze sharing. Human infants follow gaze direction remarkably early, suggesting this capacity is deeply hardwired. Language emergence likely built upon existing body language systems rather than replacing them. Early symbolic communication probably combined vocalizations with gestures, facial expressions, and body movements in an integrated package. Even today, when people speak, they automatically gesture, and prohibiting gesture actually impairs verbal fluency and comprehension. This suggests gesture and speech share deep neural connections, perhaps reflecting their joint evolutionary origin. The development of body language in individual humans follows a fascinating trajectory. Infants arrive with certain innate capacities. Newborns can imitate facial expressions within hours of birth, suggesting some aspects of face processing are present from the start. But many body language skills develop gradually through a combination of biological maturation and social learning. Young infants begin by recognizing and responding to basic emotional expressions, particularly in their caregivers' faces. By around 6 months, babies reliably distinguish happy from sad expressions. By 9 months, they follow gaze direction and pointing, beginning to share attention with caregivers. These capacities emerge on relatively predictable schedules across cultures, suggesting strong biological foundations. As children develop, they become increasingly sophisticated readers and producers of body language. Toddlers learn to use gestures to request objects, show things to caregivers, and express desires before language fluency develops. Preschool children become better at recognizing complex emotions like pride, embarrassment, and guilt. School-age children master cultural display rules, learning when to mask true feelings, when expressiveness is appropriate, how to navigate complex social situations where multiple sets of expectations collide. Adolescence brings new body language challenges. Teenagers must navigate increasingly complex social hierarchies, romantic interests, and identity formation. They become highly sensitive to peer judgment and social status, reflected in intense focus on their own and others' body language. The adolescent brain shows heightened activity in regions processing social information and reward, making peer approval neurologically more rewarding than at other life stages. This neurological sensitivity likely reflects evolutionary pressures. Adolescence traditionally marked transition to full participation in adult social and reproductive life. Interesting developmental differences suggest that body language abilities can be dissociated from other cognitive capacities. Children with autism may have normal or superior linguistic and logical reasoning abilities, while struggling profoundly with body language comprehension and production. Conversely, individuals with specific language impairment may show relatively preserved body language capacities. This dissociation reveals that body language relies on partially distinct brain systems from formal language, consistent with their separate evolutionary origins. Gender differences in body language emerge early and persist throughout life, though their origins remain debated. Research consistently shows females, on average, both produce and interpret body language cues more accurately than males. Women maintain more eye contact, smile more frequently, adopt more open postures in social situations, and detect subtle emotional expressions more readily. Whether these differences reflect biological predisposition, cultural socialization, or some combination remains contentious. Evolutionary psychology suggests possible origins for these differences. If ancestral females bore primary responsibility for infant care, enhanced sensitivity to pre-verbal infant communication might have provided selective advantages. Alternatively or additionally, lower average physical strength might have made negotiation and alliance formation more crucial for females, favoring enhanced social sensitivity. However, cultural factors clearly play substantial roles. Gender differences in body language vary across cultures, sometimes dramatically, suggesting strong influence from social learning and expectation. Cross-cultural research reveals both universal and culture-specific aspects of body language. Basic emotional expressions, happiness, sadness, anger, fear, disgust, surprise, show remarkable consistency globally, recognized across vastly different cultures with no prior contact. This universality suggests these expressions are biologically based, part of our shared human inheritance. Even very young children and individuals blind from birth produce these expressions, further supporting innate biological foundations. However, cultural variation exists in numerous dimensions. Display rules, norms about when, where, and how to express emotions vary tremendously. In some cultures, open emotional expression is valued and encouraged. In others, emotional restraint is expected, particularly in public settings. Children internalize these rules early, learning to amplify, diminish, mask, or substitute emotional displays to meet cultural expectations. Personal space norms vary significantly across cultures. Contact cultures, common around the Mediterranean, in Latin America, and parts of the Middle East, involve more touch, closer proximity, and more physical expressiveness. Non-contact cultures, including many Northern European and East Asian societies, maintain greater interpersonal distance and less physical contact. These differences can create misunderstanding when people from different cultural backgrounds interact, each interpreting the other through their own cultural lens. Gesture meaning varies even more dramatically. An innocuous gesture in one culture may be deeply offensive in another. The thumbs up, OK sign, and various pointing gestures all carry different meanings across cultural contexts. Even seemingly universal gestures like nodding for yes and head shaking for no reverse in some cultures. This variability reminds us that while basic emotional expressions may be universal, the elaborate communicative system built atop that foundation incorporates substantial cultural specificity. Thus, Adasas's evolutionary perspective suggests body language served crucial functions long before formal language emerged, coordinating group hunts, maintaining alliances, detecting deception, assessing potential mates. All these challenges required sophisticated communication. Body language provided the medium. Even after language evolved, body language retained importance, particularly for conveying emotional content, establishing rapport, and detecting sincerity. Words can easily lie, but body language, rooted in automatic nervous system responses, tells truth more reliably. This ancient system continues shaping our interactions today, operating mostly beneath awareness, but profoundly influencing outcomes. When we meet someone and instantly feel comfortable or wary, body language speaks first, activating ancient assessment systems that evolved to keep our ancestors safe and socially successful. When we sense someone is lying despite their words, body language leaks truth around the edges of verbal deception. When we fall in love, body language, pupil dilation, proximity seeking, mirroring, facial flushing, broadcasts feelings before we've consciously acknowledged them ourselves. Understanding this evolutionary and developmental context enriches our appreciation for body language's complexity and importance. These systems weren't designed by any conscious process. They emerged through millions of years of selection pressure, refined through countless interactions across countless generations. They represent accumulated wisdom about how to survive and thrive in social groups, encoded in neural circuitry and expressed through our body's endless conversation with the world. Conclusion: the endless conversation. And so our journey through the hidden language of the human body comes to a gentle close. We have explored how faces speak in thousands of subtle expressions, how cells converse in chemical signals, how postures reveal inner states, how voices carry meaning beyond words, how the autonomic nervous system broadcasts honest signals we cannot control, how chemistry shapes our connections, how to read the messages bodies constantly send, how communication fails when systems break down, and how technology is extending our ability to decode these ancient signals. But perhaps the deepest lesson is simply this: you're always communicating, even in silence, even in stillness. Your body speaks. Your cells exchange millions of messages every second. Your face makes micro adjustments as thoughts and feelings flow through you. Your posture tells a story about how you relate to the world. Your voice, when it comes, carries layers of meaning in every quality and inflection. Your autonomic nervous system broadcasts your true state through signals you can barely influence. You participate in a constant conversation with yourself, with others, with the entire living world. This communication happens mostly beneath awareness, orchestrated by brain systems older than conscious thought. Yet it shapes every interaction, every relationship, every moment of social life. When you meet someone and instantly feel comfortable or wary, body language speaks first. When you notice a friend is upset, despite their words claiming otherwise, you're reading signals they may not even know they're sending. When you feel tension in a room before conflict erupts, you're detecting a symphony of subtle signals that your conscious mind has not yet interpreted. Understanding this hidden language doesn't require becoming an expert analyzer of every gesture and expression. Rather, it invites greater awareness, deeper attention to the whole person, rather than just their words, recognition that we all communicate on multiple levels simultaneously. It suggests that truly listening means attending not just to what people say, but to how they say it, how they hold themselves, how their bodies reveal what their words might conceal. This awareness can deepen empathy. When you recognize that someone's closed posture and monotone voice might reflect depression rather than disinterest, that awkward body language might stem from autism rather than rudeness, that stress signals might indicate genuine distress rather than deception. You create space for compassion and understanding. You recognize the complexity of the human experience and the challenges we all face in communicating our internal worlds to others. At the same time, awareness of body language reminds us of our common humanity. Across cultures, across individual differences, across the vast diversity of human experience, our bodies speak a fundamentally shared language. A genuine smile produces similar muscle patterns, whether in Tokyo or Toronto. Fear creates similar physiological changes, whether you grew up in a village or a city. The basic architecture of human emotion and expression connects us all, revealing that beneath surface differences lies a common physical vocabulary of human experience. As you settle now into rest, notice your own body's language. Feel how your posture shifts as you relax. Notice your breathing slowing and deepening. Sense the tension releasing from your muscles. Observe your face softening. This is your body speaking to your consciousness, telling you it's time to rest, inviting you to let go of the day's concerns. Listen to what it's saying. Trust in the ancient wisdom of these physiological rhythms. Your body has been conducting this internal conversation your entire life, maintaining the delicate balance of systems that keeps you alive and functioning. It continues even as you sleep, choreographing the complex dance of cellular communication, maintaining homeostasis, processing the day's experiences, preparing for tomorrow. You can rest in the knowledge that these systems continue working, that the hidden language continues speaking, that the endless conversation between body and world persists without requiring your conscious attention. If this journey through the body's hidden language has interested you, I invite you to like this video, subscribe to the Silent Scientist channel, or share your thoughts in the comments below. It helps others find these explorations into the mysteries of science and human experience. But for now, let your thoughts grow quiet. Let your body speak its ancient language of rest and restoration. Let the hidden messages flow through cellular and chemical channels without trying to decode them. Simply allow yourself to be a body communicating with itself, with the world, with the vast web of connection that joins all living things in an endless, intimate conversation. Good night. The body speaks, always speaking, always listening, always participating in the great dialogue of existence. Sleep well.